The technology sector, and to an extent the way the world now works, is inextricably linked and dependent on two companies that most people haven't even heard of. These two companies have a monopoly in their markets. They are critical to the supply chain they operate in that underpins the technological advancement we see today. This leverage has put both companies in a phenomenal position, such that they can dictate their terms and pricing to customers, which has led to them becoming some of the most valuable businesses in the world, with growth rates of about 400% in the last 5 years alone, and demand for their products that is only accelerating. And this has led them to having massive influence with customers that include big tech and even governments worldwide. This is the story of how ASML of the Netherlands and TSMC of Taiwan are the kingpins of the silicon chip industry, an industry that powers everything in modern life, from our phones and computers to cars, fridges, and even our toasters. In addition, silicon chips are critical for use in the military and in defense, essential to national defense systems, used in aircraft, naval ships, military vehicles, drones, and missiles. This is the story of colossal machines and tiny chips that are shaping the very fabric of our modern existence. But where do ASML and TSMC fit into the semiconductor ecosystem? How do ASML and TSMC collaborate? And what is their impact on big tech and governments? And what makes these two companies unique that gives them an enviable level of influence and leverage such that governments safeguard their operations? Silicon chips have become an indispensable part of our modern world. Silicon-based transistors, which are the building blocks of chips, have consistently followed Moore's law, roughly doubling the number of transistors in a dense, integrated circuit approximately every 18 months. This growth has resulted in the exponential increase in computing power, leading to the devices we see today. At the same time, as manufacturing techniques have improved and miniaturization has progressed, the cost per transistor has decreased dramatically, allowing for more affordable electronics for consumers. Silicon chips can be programmed to serve many functions, which means devices can be tailored to specific needs by modifying the software, rather than designing the hardware. This is particularly the case with chips like microcontrollers and field programmable gate arrays, or FPGAs. The capacity and capability of silicon chips are key to the digital revolution. Almost every aspect of modern life, from communication and entertainment to banking and healthcare, relies on the digital processing power of chips. Silicon chips are at the core of research and advancements in numerous fields, including artificial intelligence, quantum computing, and biotechnology. The semiconductor industry, driven by the production of silicon chips, is a massive contributor to the global economy. It has fostered countless jobs, companies, and innovations. In essence, then, silicon chips serve as the brain for countless devices and systems in our world. They have ushered in a technological revolution, transforming the way we live, work, and interact with our environment. The critical global importance of chips is underlined by the fact that there is a geopolitical standoff right now between the world's superpowers, the US and China, around the source and supply of chips. The supply chain of semiconductor chips is intricate and spans the globe. It involves a multi-step process that includes multiple sectors, companies, and geographical locations. Beyond raw material extraction, from sand to produce the silicon wafers, and the mining of rare metals and chemicals such as gallium, arsenic, and other materials, companies produce thin wafers from silicon ingots. These wafers serve as the substrate on which the chips are built. Only then do you get the chip design, the speciality of companies such as Nvidia, ARM, and Qualcomm. However, these companies are not involved in the manufacture process itself. The front-end manufacturing is done by other companies that focus on processes such as photolithography to imprint patterns onto silicon wafers, and ion implantation and etching that introduce impurities into the silicon to modify its properties to create the intricate patterns of transistors. This is what ASML does. This then leads to the back-end manufacturing process that involves the assembly, testing, and packaging. Then we move into the domain of foundries, which are dedicated chip manufacturing plants. This is the focus area of TSMC. This is then followed by distribution to the end users, who are OEMs like Apple or Samsung, who integrate these chips into their products, from smartphones to laptops to smart TVs. As you can imagine, this can be a fragile supply chain that can be susceptible to geopolitical issues, natural disasters, trade disputes, etc., which can affect the flow of materials or of the finished products themselves. Any such challenges can have ripple effects across various industries, highlighting the critical role semiconductors play in the modern economy. ASML, or Advanced Semiconductor Materials Lithography, is a Dutch company that was founded in 1984 as a joint venture between the Dutch company Philips and the American company Advanced Micro Devices, or AMD. The aim was to develop photolithography machines for the production of integrated circuits, or semiconductor chips. In its early years, ASML faced competition from more established players in the photolithography sector, such as Nikon and Canon. However, through technological advancements and acquisitions, the company managed to expand its market share and grow its reputation. In 1988, Philips decreased its stake in ASML, making it an independent company. And by the late 1990s, Philips had divested all its shares. Over the years, ASML shifted its focus to more advanced lithography techniques, particularly immersion lithography in the 2000s, and later extreme ultraviolet lithography, or EUV. The development and commercialization of EUV technology is what positioned ASML as a unique player in the semiconductor equipment sector. The company bolstered its position in the industry through strategic acquisitions, including the acquisition of Silicon Valley Group in 2001, which underlined ASML's position in the photolithography market. ASML's EUV lithography is a cutting-edge technology that uses extremely short wavelengths of light to create more precise and smaller patterns on wafers. This allows chip makers to produce more powerful and energy-efficient chips with smaller transistors, a crucial advancement as the industry pushes the limits of Moore's law. ASML is the only company in the world that produces EUV lithography machines, giving it a unique position in the semiconductor manufacturing industry, resulting in its monopolistic position. Today, ASML stands as one of the most critical and influential players in the semiconductor manufacturing process. TSMC, or Taiwan Semiconductor Manufacturing Company, was founded in 1987 by Dr. Chang and is the world's largest and most influential dedicated independent semiconductor foundry. This means it manufactures semiconductor chips based on designs provided by its clients, who are often fabless semiconductor companies, i.e. companies that design but don't produce their own chips. As such, TSMC plays a crucial role in the global electronics and semiconductor industry. TSMC introduced the pure-play foundry model, which separated semiconductor manufacturing from design. This allowed design companies without fabrication facilities or fabless companies to get their chips manufactured. This business model innovation was a major disruption in the semiconductor industry and led to the rise of many fabless semiconductor companies that we know today, such as Nvidia, ARM, and Qualcomm. Throughout the 1990s, TSMC expanded its manufacturing capabilities, capacity, and technology offerings. It established multiple fabs or manufacturing facilities in Taiwan and continually refined its processes. TSMC was among the leaders in advancing semiconductor manufacturing processes. They have been instrumental in driving the transition to smaller and more efficient process nodes, like 7 nanometer, 5 nanometer, and even 3 nanometer technologies. This has made TSMC the go-to foundry for advanced chip designs, resulting in its monopolistic position. TSMC bridges the gap between chip designers and the physical chips that end up in products. Given its scale and technological capabilities, TSMC is a linchpin in the global tech supply chain. Many of the world's electronic devices, from smartphones to computers to servers, rely on chips produced by TSMC. TSMC is not just important, it's foundational to the modern tech industry. Its manufacturing capabilities touch almost every sector that relies on advanced electronics, making it one of the most influential companies in today's interconnected world. Although they operate in different parts of the semiconductor supply chain, ASML and TSMC's collaboration is integral to the production of the latest and most advanced chips. As discussed, ASML focuses on providing the photolithography equipment used in the chip manufacturing process to define patterns on silicon wafers, whilst TSMC takes care of the eventual manufacture of the physical chips themselves. As such, TSMC is a customer of ASML and buys the EUV machines to help with the manufacture of the chips. Given the strategic importance of EUV technology in next-generation chip manufacturing, and the fact that ASML is the only supplier of EUV lithography machines in the world, the relationship between ASML and TSMC is not only that of supplier and customer, but also of close collaborators in advancing semiconductor technology. In recent years, TSMC invested heavily in extreme ultraviolet EUV lithography via an investment in ASML alongside other major semiconductor companies. Under a 2012 agreement, semiconductor company investors including TSMC, Intel, and Samsung acquired a minority stake in ASML in exchange for providing R&D funding for ASML. The collaboration was strategic for companies like TSMC because having early and reliable access to advanced lithography technology is crucial to maintaining a competitive edge in the semiconductor manufacturing industry. It is this position at the cutting edge that allows ASML and TSMC to be essential to big tech and governments worldwide, resulting in the current chip wars. Both ASML and TSMC are central pillars of the semiconductor industry and are well positioned for future growth and developments. ASML's monopoly in producing extreme ultraviolet lithography machines, or EUV machines, cements its importance in advanced semiconductor manufacturing. As chip designs continue to shrink and demand precision, EUV technology will become even more essential. ASML will likely continue its heavy investment in R&D to further refine EUV technology and explore next-generation lithography methods, keeping it at the forefront of the industry. The global demand for semiconductors is increasing. As more manufacturers look to adopt advanced chip-making techniques, the demand for ASML's machines will likely grow. TSMC has been leading in transitioning to smaller process nodes, with plans already in place for 3nm and even 2nm technologies. TSMC will likely maintain its position at the forefront of advanced semiconductor manufacturing. Recognizing the strategic importance of a diversified manufacturing base, TSMC may consider expanding its operations outside of Taiwan. There are already plans underway to build advanced fabs in countries like the US, for example. More broadly, the semiconductor industry is at the intersection of technology and geopolitics. Both ASML and TSMC will need to navigate evolving geopolitical landscapes, trade dynamics, and potential regulations. Given the complexity of modern chip design and manufacturing, collaboration across the industry will be essential. This means ASML, TSMC, and other industry players will likely need to work even more closely together to aid future technological advancement.